AP Chemsters, this is Mrs. Vanderwall bringing you another blank wall. This is Blankwalle, Chapter 6, Section 8, Part 2. In Part 1, we learned about Hess's Law and the rules in order to do that. We had learned that if you multiply or double the coefficients of a reaction, you need to do the same thing to the heats. If you recall from that lab that we did at the beginning, when you added more calcium chloride in the baggie, the more calcium chloride, the more heat you got. So you need to show that using your delta H and then multiply it by something. We learned that if we reverse the reaction, so we flip the products and reactants, we need to reverse the sign as well. And then you add up all your things that you have and you cancel out anything that appears on both sides, and then you add up your delta H's. This is a very useful tool in solving for enthalpy. It's not the only one. We're going to learn another one in section 6.9, but let's just keep working on Hess's Law for right now. So this problem, problem 42, is probably one of the hardest ones you're going to come across. There are 4 reactions down below in which to manipulate to get our goal. So let's see how we're going to do this, and I'll give you some more hints, and then I'll let you try to figure out some of the other ones on your own. This one says diborane is a highly reactive boron hydride that was once considered as a possible rocket fuel for the U.S. space program. Just a little background that Herbert C. Brown from Purdue University got his Nobel Prize in his boron research and trying, he was the one that was working on making this lightweight fuel out of boron. Think of how lightweight it is, all right? Boron is a very small molecule with a low molar mass. But anyway, I just thought I'd throw that in for you, okay? Anyway, it says calculate the delta H for the synthesis or diborane from its elements according to this equation. All right, and look at all these reactions below. What the heck are we going to do? You remember my my helpful hint is like start here. Where is boron solid located? Boron solid. Blah, blah, blah. Oh, it's right up here. Okay, so I need 2B, but not 2B, I guess. No, I need 2 borons, and I have 2 borons. So that's pretty cool. I don't have to do anything with that reaction, do I? I'm going to scroll this down a little bit, okay? So that first one, made a little check mark. Oh, that's done. All right, now I need some H2 gas. So look around. Where's some H2 gas? Oh, letter C. Here's an H2 gas. All right, but what's different between this H2 gas and this H2 gas? Oh, it's the coefficients, right? So if I scroll down a little bit, here we go. I need this. Oh, stop that. Well, I'm going to scroll this up here, and I need 3 of those. Yes, I do. And so if I need to multiply this by 3, don't I need to multiply your delta H by 3? And the answer is yes. And so when I do that, I believe I get negative 3819. So this is what I get when I multiply everything by 3. Okay, so I could ignore now this second line here, right? So I can just take this second line out. So I can just kind of flip it up here so I don't get too confused. I've just used this. I'm going to flip it up here so I don't get too confused. So here are my 2 reactions. Oh, I left out my arrow. Here it is. And here is this. Okay. Now what? I got my boron all taken care of. I got my hydrogen taken care of. Hey, do I have B2H6 anywhere along here? Oh, I don't. So now what? Where's some B2? Oh, letter B has some B2H6, doesn't it? What's wrong with that? All right, my B2H6 is on the reactant side. My B2H6 is on my product side. So what do I need to do to this? I need to, do you notice that? I had to flip it, didn't I? Okay. So I have one more thing to do. If I start canceling stuff out, all right, let's see what I can cancel out. All right. All right, so I'm working on this, and it's like, okay, what kind of things can I cancel out maybe? All right, I have the boron, diboron, trioxide or whatever, and well, that cancels out. And what if I were to add these guys? What's 3 halves plus 3 halves? Isn't that equal to 3? Well, then, yeah, it does. So then I can cancel out these guys. All right, but I can't cancel out my waters, can I? Why not? This is a liquid, and this is a gas. I can't cancel them out. So what do I need to do now? I need to use letter D here and help me out. I need to put the gas on the right side and the liquid on the left-hand side so they do cancel out, and here they are. So now that I've canceled those out, those cancel, those cancels. So now what? What do I have to do with my delta H? Well, my delta H, I multiplied it by 3, right? So what's 3 times 44? It is 132. So now I'm going to move this out of the way so I don't have to worry about it. I'll move down here. All right, and so here's my delta H, okay? So I'm ready to rock and roll. I have, when I'm all set and done here, that when I add this all together, I have 2 borons, 3 hydrogens, and then 1 diborane, and that's what I want, okay? So what am I going to do here? Whoops. What am I going to do here? I'm going to add up all these numbers, and I hope I add them up right, and I got negative 2793. So if I didn't add them right, I apologize. I think I did, though. And so that's how you would go ahead and solve this. It says on the basis of the enthalpy is a use or reaction for the synthesis. Well, I'm not really sure what this means, so let's not even worry about it. Let's go to the last problem. All right, problem number 43. I'm going to let you work on this yourself. Remember, that's your goal. And pause this. When you're done, come back and see how you did. All right, welcome back. Well, how'd you do? Well, the first thing I did was looked at my goal. I need 3 carbons, and here's where my carbon is. So I multiply everything by 3, and so I got 3 times negative 393. So that's what this is all about. So right here, so I can maybe get rid of this over here because I just figured that out. And next I need 4H2. Well, let's see here. This is the equation that I need 4H2, right? So I multiplied this by 2, and I got the second one here, so I can just kind of get this one out of the way now, right? So here's my first one, here's my second one, and now I need C3H8 as my product, and here is where it is. It's over on the other side, but hey, wait a minute, what did I have to do? I needed to reverse it, right? So I had to reverse this equation and make it a positive, and so when I'm all done, let me see here, here's my line. What did I get? So let's cross out things that are in common. Okay, I have 3 plus 2. I have 5 oxygens here. I have 5 oxygens here. I have 3 carbon dioxides, 3 carbon dioxides. Now, I did not put my little gases here because they both are in the gas phase, so I can cross them out. So what does that leave me with? Well, hopefully it leaves me with this. There we go. And so what do I do with all these numbers? I have to add them up. And I got this. So that's the end of Hess's Law. I hope this was helpful. We're going to be practicing more problems like this in classroom, of course. So we're done. Don't wait to be great. We'll see you next time. Bye-bye.